This is not here. So I may have to move fast. We have wasted 40 minutes first. So let me try and move fast. Adra, can you hear me? Speak up, Adra. Speak up. You are no longer mute. Hello, Adra. Hello. Okay, so I'll just move on. You have to be fast now. Hello, Adra.
I can hear you.
Okay, good. Okay, good. Let's continue. So you understand the concept that played out here now. So you have 3x squared. Abi, you are holding this 3x just to differentiate y squared. Plus, you are holding this y squared just to differentiate this 3x. Are you following me now? Hello, Adura. Did you get this? Minus, normally, you are now differentiating 2y cubed straight up. Now, just like the concept I showed the other time, I took my time to explain that concept, really. Just like that concept. So you now have 3x squared plus. Now, when you differentiated y squared, it would have given you 2y. Abi, 2y times 3x will give you 6xy, but you cannot take away dy dx because it's not dx over dx. Did you get that part? Hello?
Yes, sir.
Now, when we differentiated 3x and we had y squared, you know it will give us 3. 3 times y squared give us 3y squared. Minus, now, when you differentiated that 3, I forgot what it said, that minus 6y squared dy dx. Because you cannot cancel dy dx, is equal to 0. Why did you have 2? Because 3 itself will give you 0. When you differentiate 3, it doesn't have x, it doesn't have x. You get the idea now. Now, we now collect the like times. What are the things? Okay, let's bring the ones that won't have dy dx together. We bring them together. That was how we got this. Then we brought the rest to this place. You know, 3x squared that becomes minus. Because it does also come minus. So you divide all through by this so that we can have dy dx. Did you get that now? So that was how we got our final answer. Is it clear now? Okay.
Yes,
so let me quickly rush to example 2. Because of time, I'll just rush to example 2. We really have to manage it. Let me check. No, I'm sorry, I won't go over it again. Check the video again and again. You will understand it. You understand? So example 4x y squared plus 3xy minus 2y is equal to 3x squared plus 4. Just the same concept. Now, let's just move straight. So we have dx now. There's 4x y squared plus 3. This is meant to be 4x y squared, right? Did you get this part? This is meant to be 4x y squared, not 4x squared. This is meant to be 4x y squared plus ddx 3xy minus ddx 2y ddx 3x squared plus this. You understand this part? So this part is meant to be 4x y squared. Now, holding 4x and differentiating y squared. Holding y squared and differentiating 4x. So we are through with this. Now coming to this. Holding 3x and differentiating y. Holding y and differentiating 3x. Are you following me? Minus normal differentiation y. Now we come to this. You just normally differentiate x squared. Then you differentiate 4. Are you following me, Adura? Are you there?
Yes, sir.
Okay, good. So now when you differentiate this, this will give you 8xy. Because we are differentiating y, you will still have your dy dx. Now this place where you differentiate your 4x, we have 4, it will give you 4y squared. Now when we move to the next, when you differentiate y, it will give you dy dx. 1 times 3x will give you 3x dy dx. I don't know if you understand that part, please.
Yes, sir.
Good. The next, this place, when you differentiate 2y, the answer will be -2. Then you still have your dy dx. Because you are not differentiating x now. Then this one is obviously +0. Did you understand this part? Okay, so let's just move. That this is the last line. Now you can now also look for common terms, right? Let's bring the dy dx. This one has dy dx. So you have 8xy. This one is another dy dx. You have 3y. Then this is another dy dx. You have -2 dy dx. Is this one clear?
Yes, sir.
Now bring 4y squared to the other side. It gives you -4y squared. Then bring 3y to the other side. It gives you minus what? -3y. So divide through by this, so you have dy dx to be equal to this final. Let me check if there's anything. Sure, I will make sure I post. I stopped posting on my YouTube channel. I did not post last class on YouTube channel because I realized that most people don't go there to watch. I realized that the view is actually low, maybe 6 people, maybe 5 times, and it cost me a lot of data to post on YouTube. So that's why I stopped posting it. I will post this one so that some of you can have the opportunity to look through it. All right, and please kindly remember to subscribe so that you can always have the video every time I upload new class. Okay, next example. Who would like to go with me? The last example, example 3. Who would like to work with me? Say I if you'd like to work with me there so that I can release you. Julia, I thought you are not. Julia 1, then after Julia, who is the next person? Julia Joy. Hello, Julia. Adra, mute yourself. Hello, Julia.
I hear you. Okay, sir, I can hear you now.
Very good. So, who is the next person? Adeleke, it won't be you. You that say I should be fast. It won't be you. Somebody else. Infinix. What's your name? Infinix Hot 5. Huh? Okay, let me release you. Yeah. Okay. ITEL A32F. What's your name? Please.
Adita.
Madam Adita. Okay, it's you. You didn't sign in with your account. That's why. Okay. So let me work with Julia and Anita. Julia, I will remove you except you show us. We can only
That we talk.
No, we want to see people that we are working together.
Me. So I'm there.
Okay, no problem. Okay, so we have 4x, 4 cos x sin y plus 2x cos y is equal to 3y plus 2x minus 5. Are we together? Guys, are we together?
Yes, sir.
Anita, you are not talking.
Yes, sir.
Yes, sir.
I will remove you. Okay.
Yes,
Now,
sir.
the same concept. Now, follow me. The same concept. Holding 4 sin x. Are you getting me? Differentiating sin y. This place is very with it. Are you getting me? Plus holding sin y, differentiating 4 cos x. Is that one clear?
No, sir. Sir,
Yes,
is it not?
sir.
Sir, is it not holding 4 cos x, differentiating sin y?
Check this. We add 4 cos x as 1 to differentiate sin y. Abi?
Yes.
So we are now holding sin y to differentiate 4 cos x. So this is your A, this is your B. You remember?
Okay, yes.
So let's do for the next one. We have 2x cos y. So we are holding 2x to differentiate cos y. We are holding cos y to differentiate 2x. That one clear? Now we cannot just continue.
Yes, sir.
You differentiate this 3y, Abi?
Yes.
Then you differentiate this.
Yes, sir.
If you differentiate y, it will give you 3 dy dx.
Right, yes.
from what I just taught you guys. Anita, what happened? So if you are differentiating 2x, the answer will be why is
2,
the
yes.
answer 2? Yeah. Why the answer is 2?
What did you say?
When you differentiated
it's 2.
When you differentiated 2x, why is your answer 2?
Sir, you know, when it's 2x, means the x is raised power 1. So it's more like 1 times 2, that's 2. Then 1 minus another 1, that's 0. So x raised power 0 is actually 1. So 1 times 2 is 2.
No.
Yes.
I just shared a new concept this class.
Sir.
I didn't hear that word.
I just shared a new concept in this class so that you can understand. I said when that x that you remove, Anita, you actually added it to d. So the x over the x will now give you 1. 1 times
multiply
3
by
3. But when we add for 3y, when we are differentiating for y, are you getting me? The y cannot cancel the x.
Yes.
That's why we still maintain dy dx in front of 3. Unlike this place that we did not have it as 2 dx dx. The x already cancelled the x. Anita, did you get that part now?
Yes, sir.
You now understand that concept now?
Yes, sir.
Good. So let's move forward, guys.
Yes, sir.
Okay. After this class now, there are people I've not been hearing from. People from sciences, where are you? FOS. Nobody from FOS. I've not been seeing you. No problem. So now check this place. Check this place. So now when you differentiated cos y, are you getting me? So sorry, when we differentiated sin y, the answer that gave us what? Cos y. Are you getting me? But you won't take away dy dx. If it had been sin x, you wouldn't have this again. You know.
Okay.
Are you there? Hello?
Yes, sir.
Julia?
I'm hearing you.
Okay, good. Now, so next one now. When we differentiate cos x, 4 cos x, you know your 4 will come outside. Cos x is turned to what? When you differentiate cos x, what do you have?
Yeah.
When you differentiate cos x, what do you have?
Sign.
Eh?
Minus sign.
No, it's not minus sign. When you differentiate cos x, what do you have? It is minus sin x, not minus sign.
That's what it said. Oh, minus sign x.
Yes.
Is that what?
Minus sign x.
Good. So that is why you have minus. That minus is what you have here. That affected that plus we had before. That's why you now have minus 4 sin y sin x. That is why you did not have dy dx, because we are dealing with x here. Is that clear?
Yes.
Now, let's get to the next one. Now, when you differentiated, I think we had cos x. When you differentiated cos x, are you getting the idea now? The answer gave you what? Minus sin x, when you differentiated cos y. Okay, let me confirm. Okay. Okay, so we've done this. So now, yes, when you differentiated cos, no, we've done this. I think this is the next one. So if you differentiate cos y, it will give you minus sin y, Abi. So you have minus 2x sin y,
Sin y.
d dx. You understand the idea?
D dx.
Yes, because we are differentiating y. That's okay. This is the concept. If you are differentiating x, that d dx will not be there. If you are differentiating y, your d dx will come back.
Okay.
Have you got to that concept? It's very important to understand this thing, please. Hello.
Sir.
Yes, I can hear you.
Sir.
Talk now.
So if you are differentiating x, that would change to 1, Abi.
Exactly, because it will give you dx over dx 1.
That is 1. Then if you are differentiating y, that would be the y dx, and it will cut each other.
They can't cross each other, So that's how you have that dy dx there. Are we clear?
Yes, sir.
I'm not sure Anita understood this part. I really want us to get this part.
No, sir, I understand. I'm just trying to write it down now so I don't forget.
Okay, good. So now check this place now. So when you differentiate 2x, what will you have? 2 cos y. Are we together?
Mm-hmm. Yes, sir.
Are you sure?
Yes, sir. Yes,
so
sir.
Let's check whether we are right. That's how you have 2 cos y here. Hello? Can you all hear me?
Yes, sir. I can hear you.
Okay. So we now have 3d.
Yes, sir.
Because this is 3y. That's how you have 3 dy dx plus 2. Normally 2x. You are differentiating 2x to give you 2. You get the idea now? Are we there?
Yes.
So now, if you are now looking for, let's now collect like times as usual. So this one has d dy. So you have 4 cos x cos y. This one also have d dy minus 2x sin y. This one also have d dy. Now, this one would have crossed the other side. Excuse me, that's why this is minus. Hello? So normally there's a step between this place and this place. What is that step?
Yes.
Let's firstly collect the like times. Like, let this one come to this side. Then this one will go to this side. So it will turn to plus. Are you with me? This one will go to the other side. It will turn to plus. Then you have your 2 here. Okay, this one turns to minus. So this one turns to negative. And that's how you have this dy. And you divide all through by everything that is here. And this is your final answer. Did you understand it? Hello, guys.
Samuel, we are hearing.
Do you understand it now? Can we go to the next walk?
Yes.
Okay. Let me check if I have somebody I may need to explain one thing or the other too.
Victor.
Confused. Wow. See, if you write your attendance at the wrong time, it will be a minus mark for you. For those of you that just write attendance. Okay. Okay, we are here. Victor, do you understand what we are doing? Okay, let me try and hear from Victor. Hello, Victor.
Sir?
I hope you understood everything we've been doing.
No.
Abba. So tell me the part you didn't understand.
From this particular site, I should know.
Yeah. You got it to this point, did you?
This for
this place. Hello, Victor.
yes.
That means example 3. Hey, what's all this now?
Yes, that
example 3, Abi.
yes.
Is that a problem, Victor? Okay, let me quickly run you through it again. Follow me, please, Victor. Right? So the concept we have been using is you hold one, you differentiate the other. You hold one, you differentiate the other, just like product rule.
Yes,
remember?
Sir. Yes, sir.
Okay, good. Now check this part. 4x, just normal ddx, 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 ddx. That's what happened here. We just place dx for everything. Like we are differentiating them one by one, just like nominal rule. That's the process that happened here. Are you with me?
Okay.
Now,
yes.
When you differentiate sin y, what will it give you? That's why you're having sin y holding 4 cos x plus
Okay.
you are holding sine y to have 4 cos x. Hello, you didn't get that part. When you have equation like this where you have x and y, you will firstly differentiate x and hold y, add it to holding y and differentiating x, and that was what.
Okay.
You know, this thing is annoying, guys. For those of you trying this rubbish, you are wasting our time. You are affecting everybody, wasting their data and distracting us. Okay, so now that was what happened. So you add your 4x differentiating sine y. You add your sine y differentiating 4 cos x. Are you there now, Victor? So you add your 2x differentiating cos y. You add your cos y differentiating 2x. Do you understand the concept now?
Okay.
Now let's now go ahead and differentiate. If you differentiate sine y, it will give you cos y. Are you getting me?
Yes, sir.
However, it will give you cos d dy dx because it is not x, it is actually y. Are you following me now? So that's why you had.
Yes.
That's why you had cos x cos y dy dx.
Okay.
Are you there? Now, if you are differentiating cos x, you know 4 will come outside. So you have 4 sine y. Cos x will give you minus what? Sine x. Because it is xx, this one will not count. It will not cancel this dx because dx over dx. Are you getting me? We now be out of the thing. Are you following me? So you now be left with minus 4 sine x sine y. Let's see if that's what we have. Minus 4 sine y sine x. You know, it's still the same thing. Are you following?
Yeah. Yes,
sir. The same thing played out here. The same thing played out here. When you differentiate cos y, it will give you what? Minus sine y. So you now have what?
Minus sine y.
Minus sine 2. Are you getting me? 2x minus 2x sine y dy dx because it is y.
Dx.
Are you getting me? Now when you are differentiating 2x, it will give you 2 and the x is out. So you have 2 cos y. And you should understand this one normally. So that was how you got. So that was how you got this. Now, the next step is to collect the like times. Are you following me? Now, let's collect the like times that add dy dx. So this one add dy dx, this one add dy dx, and this one add dy dx. Now, why is it now minus 3? Because this 3 already crossed to the other side, and it's not giving you negative. Is that clear, Victor?
Yes, sir.
Good. Now, let's push. Let's push this one to the other side. It will give you plus. So you have these 2 plus this 4 sine y sine x. Then this plus will give you what? Minus. Then divide everything by what is here. So that your dy dx can be 2 plus this and this. Did you get it now, Victor?
Okay, yes, sir.
I want to hear you clap for me.
I understand.
You didn't hear me. I said clap now. Aha, good of you. All right, so guys, let's walk through the next example. Ismail, are you in class? Is Ismail in class? I've not been seeing Ismail in class. I've not been seeing Jumoke. Jumoke is not in class, not Ojewola. Jumoke of FOS is not in class. I need another person from FOS that I would like to walk through. Who is this other? Abiola, you are not in class. Abiola is not in class. Okay. Yeah, Emmanuel Akode, we'll do this together. You have been busy drinking. Hello, Emmanuel. So we'll do the next example together. I need one more person to join this example. Okay, Jessica. Let me work with Jessica. Okay, Jessica. Hello, Jessica. Hello, Jessica. Hello, Jessica. Are you there? Okay. Emmanuel, are you there? Akande? The next example, I won't go back. The guys I called are not responding, so I won't go back. The next example is differentiation of inverse trigonometry functions. So how do you differentiate? This place is very technical. So I'll need you to really concentrate, please. I don't want to explain and re-explain. I think Emmanuel is not ready. Let me work with people who are ready. If you want to work with me, kindly say hello, so that I'll work with those two people. Let me see two people that want to work with me, so that I'll walk them through. Ifeoluwa. Okay, Ifeoluwa, very good. I thought I called Faye already. Biobaku, I will release Biobaku now. Hello, Ebu.
Sir?
Been a long time. How are you?
Hi, sir.
We can't see your face, so. Okay. Very good. Very good. Okay, so who is the next person? Faye. Hello, Faye.
Sir?
Where are you? Let's see you.
Sir, I'm here.
We want to see your face, so. Where's your face?
Hey. Mado.
Who is that? This is you, eh?
Sir?
Okay, this is you. This is your face. You are the one troubling us. Okay, no problem. So let's begin from here.
Me?
Good. Different. Ebun, are you there?
Yes, sir.
Okay, good. Differentiation of inverse trigonometric functions. So when you're asked to differentiate sine arc x, how do you go about it? Now, you know that this can also be written as sine y is equal to x.
1 over sine x.
I hope you know. Amajola,
Sir?
I hope you know this is also equal to this.
Yes, sir.
Biobaku, do I need to explain this?
No, sir.
Very good. Very good. So all of us agree. So now we are now going ahead to differentiate this. Instead of differentiating this, let's differentiate this. At least let's start with something very visible. Let's take this arc away. That's what led us to this part. We want to take away this arc. Are you getting me? So it says sine y is equal to x. So we are differentiating with respect to y. So that's why you now have d dx over sine y to be equal to d dx over x. Excuse me. And like I told you, this is equal to what? 1. Abi?
Yes. Yes. Yes, sir.
Good. Now, when you differentiate your sine y, what will it give you?
Cos x.
Bad
Cos
memory.
x.
She don't
Oh,
memorize
cos y,
everything.
cos y, cos y, cos
She
y.
has
Cos
memorized
y.
everything.
Cos y.
La cram, la
Cos
pom.
y.
Okay, so we have cos y.
Cos y.
So we now have dy over dx. You know why we have dy x? Because we are
Yes, because they're
differentiating with respect
differentiating
to
y.
Good of you. So now, let's move to the next slide. Now, you may need to be careful here. The thing is not clear. So you just have to concentrate very well. So now, you know that if you differentiate, now, if you check this place, so let cos y move to the other side. Divide both sides by cos y. That was how you had 1 over cos y. Did you get that part?
Yes, sir.
No.
Ebun, you didn't get it.
I did not get it.
Okay, check this place. Divide through by cos y. Remember how we normally do it now? Now divide through with what is in front of this.
Okay.
Divide through with what is in front of
Yes.
in front of divide dx. You remember now? Ebun.
Yes.
So that will give you actually dy
Sir?
dx is equal to 1 over cos y. Do you agree now? Eh?
Yes. Yes, sir.
You understand this part now? So that was how we have
Yes,
dy
sir.
dx is equal to 1 over cos y. Are we following? Now you have to be careful here.
Yes. Yes, sir.
Now, you will remember that sine square y plus cos square y is equal to 1.
1. Yes.
You remember that? Now these are
Yes, sir.
mathematics. You just have to understand this part. More or less like you are cramming what you are doing. So that somebody will not say this is his final answer.
Mm-hmm.
Are you following me now? You know, somebody will say this is my
Yes,
final
sir.
answer now.
Yes, sir.
But no, this is not the final answer. Because what we are dealing with here is actually inverse trigonometry. So now you move further, like, okay, sine square y plus cos square y is equal to 1. So that means cos square y is equal to 1 minus sine square y. Hello?
Yes.
Did you get that part?
Yes, sir.
Now,
Yes.
if you divide through by square root, like let this square that is here, let it go to the other side. So that's how you have cos y to be equal to square root of 1 minus sine square y. So one day we'll be walking somewhere. I will say recall that cos y is equal to square root of 1 into bracket 1 minus square y. Somebody did not get that part.
I get.
No, did you get that part? That
Yes,
cos y
yes, sir.
is equal to square root of 1 minus sine square y. You now understand? So that's why you now have dy dx is equal to 1 over 1 minus x square, all in square root. So you've been able to take away anything called what? Because where did you get your, you know your sign now? You know your sign y is what? What is your sign y? Ebu,
X.
what is sign y? We can't hear you.
I think X squared.
Sin y cannot be x squared. What is sin y? Some of you, I expect some of you, you remember here now, I expect some of you to already have your notes already now. Sin y is equal to x. You remember now? Sin y is equal to x. So when we got here, okay, all right. So do you understand, Finn, Ebu? You understand this now?
Yes, sir.
Okay.
Yes, sir.
Let me allow Tinu to talk. Hello, Tinu.
Hello, sir.
Yeah. So, wait, just hold on. Who else? Please send the video of today's class. Please, okay. Okay. Infinix Smart. Infinix Smart. Let me check you out. Infinix Smart. Okay. Ask your question, Tinu. Where did you got confused?
This current example.
From the beginning.
This current example, this example we are doing now.
I mean, like from this place itself.
Yes, yes.
Okay, so now you understand how we got sin y to be equal to x from this place. Do you understand?
I don't understand.
Now, this is normal. Are you getting the idea now? You know, this is arc. Now, it's just like you are transferring this sign, multiplying this sign. Now, this is what happened. If this sign, if you divide through by sign, are you getting me? It will give you y is equal to x over sign. Are you following me? Hello, Tinu? Hello?
Hello?
Can you hear me?
Hello, sir. Yes, I can hear you now.
I said, are you aware? My goodness. Okay, are you aware that, okay, let me show you what happened from this place to this place. I'm coming, let me share my whiteboard. No, see, we had, can you remind me, we had y to be equal to sine arc x, right?
Yes, sir.
Good. Now, we now said that is actually equal to sine y equal to x.
Mm.
Now, let me show you what happened here. What really played out here. Now, if you multiply through by sign, multiply through by sign. So this will give you y, Abi, multiply by sign. Sorry, y multiply by sign. Are you following me?
Yes.
To be equal to sine arc x, Abi, multiply by sine. Are we together?
Yes.
Now, you know that this one will cancel this, isn't it?
Yes.
So that means you now have sine y to be equal to x. You now understand?
Okay.
You
Yes,
got
sir.
that part already, right?
Yes, sir.
Very good. All right. So now let's quickly let's return back to our slide. So that was how we got this. Now you should understand the idea of our differentiation before. You got previous examples, right?
Yes.
So you have your d dx sine y, then your normal d dx of x. Now I told you that the reason this one turns to 1 is because dx divide dx. Abi dx cancel dx. So you have your 1. Abi. Now when
Yes,
you
sir.
differentiate sine y, what will it give you?
Cos y.
However, because it's y, you will still have your dy dx. You understand this idea? I already explained this concept. Why you have your dy dx here.
Yes, sir.
Now what we are looking out for is dy dx. That means you divide all through by cos y. So your answer will now be equal to what? Dy over dx is equal to 1 over cos y. Is that clear?
Yes.
Hello?
Yes, I'm with you.
Okay. So that was how we have dy dx is equal to 1 over cos y. Now, I remember we've had to talk about this in our previous example that sine square y plus cos square y is equal to 1.
Yes.
Good. So now you can now go by this by saying cos square y is equal to, take this one to the other end. So that's how you have 1 minus sine square y. Now, we want to take away this square. So we can square root of both sides. A square root of both sides, we take away this and we have square root here. I don't know if you understand up to this point.
Yes.
Okay, let me get my pointer, I think. Okay, you understand it to this point now?
Yes.
Now, you remember that sine square y, sine y was equal to x. Have you forgotten? That
No, sir, I'm with you.
that x is equal to sine y. You remember?
Yes.
Yeah.
Yes.
From this place. Abi? So that
Yes,
was
sir.
what that happened here, that this square is this same square here. So this is your x. So your final answer is that 1 over square root of 1 minus x squared. Did you get that part, please?
So where is that one coming from? The last.
This is your 1 now. This is your 1. This is your 1. 1 came in from this place. Sine square y plus this. Check this one. This is the one. This one has been there from the onset.
Okay.
We return back to it's called, we want to know, we have now concluded, we want to show you, what we are trying to do is to show you how we arrive at cos y is equal to square root of 1 minus x squared. So we have concluded that cos y is also equal to 1 minus x squared. Are you now with me now?
Yes, sir.
So we just put that one here and that settles it. Omojola, did you get it very well? Julia? Hello, Julia. Julia, okay, I can't hear her. Is Julia there?
Yes, sir.
Did you understand it very well now?
Yes.
Very good. Ebun, how about you? You got that part well? Hello, Ebun.